Welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, in a previous few lectures we were able to discuss our topic understanding time series. So, we will move to our next topic, that is regression based forecasting methods. So, in this particular topic in coming few lectures and this lecture as well, we will be discussing about how a regression based how regression models can actually be used to forecast a time series. So, let us start our discussion. So, as we can see in the first point itself, based on multiple linear regression models, if we look at from the modeling perspective, so typically we focus on only two time series components, trend and seasonality. So, in our discussion in previous few lectures, we talked about four time series components: level, trend, seasonality and noise, wherein we also discussed the importance of trend and seasonality. So, in this particular topic, in this particular method, regression based forecasting method, we will see that how trend and seasonality are important in terms of building model for forecasting future values. So, why regression based forecasting methods are popular for predicting time series? So, few points have been discussed here. Main idea behind using regression based methods is to capture two aspects, these two aspects of a time series well, the trend and seasonality. So, if we are able to make certain reasonable assumptions about the structure of data, the kind of trend that is there and seasonality that is there. So, the seasonal pattern and the trend that is there, if we are able to make certain reasonable assumption about these two, then regression based forecasting method can actually be used to model to capture these two aspects, and also to incorporate relevant predictors. Since we are if we use regression based forecasting method, so there is always a scope that if there is any relevant predictor, we can also include it in our regression modeling equation. So, let us start with the first one, that is trend. So, we will start our discussion on how we should go about modeling the trend component. So, as we have discussed before also, there are three common types of trends that we would be focusing on. First one is linear, then exponential and polynomial. So, we will discuss each of these trends one by one, and we will see how these trends can actually be modeled using regression based method. So, let us start our discussion with the first one, that is the linear trend. You would see in this point I have also mentioned global. So, this is to indicate this is to refer to the discussion that we had in previous lectures, where we talked about that model driven methods or statistical methods are more appropriate when we have the presence of trend is global in nature. So, we have global trend because if we assume certain structure about the data, then that should be applicable in the entire series. So, therefore, if the nature of the trend is global, then probably regression based forecasting methods being statistical methods are going to be give better performance. So, let us discuss how this can be modeled. So, implies an additive increase or decrease of the series over time. So, this is what we mean by linear trend, an additive increase or decrease of the series over time. So, depending on the slope, line depending on the slope of the line, so it is going to be either additive increase or decrease. So, Y output variable is typically the time series variable. For example, the data set that we are using bicycle ridership. So, it is going to be the number of riders that are there. So, this is going to be the output variable, because we have monthly data on ridership. So, that is the series that we have. So, Y is that number of riders, that is the time series variable, and X is time index. So, essentially we would be regressing this Y number of riders on this time index variable. So, let us see how the model equation can be written. So, this is in reference to the example that we have been using, bicycle ridership. and we can model the number of riders using a time index as the single predictor. So, you can see here the regression equation here yt, where yt is number of riders at time point t, and then we have on the right hand side we have the beta 0 plus beta 1 t plus epsilon. So, where t is the numbers like 1, 2, 3, which is actually indicating the time index. So, in this, if we look at if we analyze this regression equation and we try to understand the different components of the time series, how they have been modeled into this particular equation. So, we can see here beta 0 is actually indicating the label, right. So, we talked about label in capturing the average values of a particular time series. So, in this case when we use this particular equation, when we use this particular regression equation, then beta 0 is actually capturing the label of the series. Then we talk about the beta 1. So, beta 1 here is indicating the trend. So, here we have right now we are modeling the linear trend. So, we have assumed that a line could actually fit the time series and indicative of the kind of change in the series that is happening, and that change is represented by the slope of the line, which is being captured by beta 1. Then we have the epsilon. So, that is the noise. So, that is the unaccounted part. So, in this from this equation, and we can also say that we are assuming that the line has a linear trend, and there is seasonality is not there. So, you can see seasonality is not modeled here, we are just modeling the trend component. So, label we can see beta 0, beta 1 is indicating the trend, seasonality is not modeled, and the fourth component is epsilon, that is noise. So, in this fashion we can see 4 component and how they are being modeled. So, what we will do, we will go back to our studio environment and see how this particular modeling, this modeling of linear trend can actually be applied on bicycle ridership data set that we have. So, let us load this library XLSX. Let us import this data set. So, you can see the data has been loaded into the environment section, as we can see here 159 observations, 2 variables. So, it is the same data set that we have used in previous few lectures. So, let us remove any deleted columns in Excel. Now, let us look at the structure of this data set. So, we have just 2 variables, one indicating the time information, that is month and year, and then we have the second variable which is riders, number of riders for each of those months. So, what we are going to do is just like in previous lecture, we will create a time series objects. So, for this we are going to create this TSV, time series vector. We will call this function TS. First argument is going to be the time series variable, which is the riders. So, we are essentially capturing the number of riders for each month for the given period. So, the first argument is this variable riders, and then we are mentioning here. So, as you can see in the previous lecture, when we created this time series object, we had mentioned the argument start and end and frequency. So, at that time I had also indicated that end and frequency, we only need to use one of those arguments and the other one will be taken care of, given that we specify the values in the appropriate format. For more information, you can always refer the help section for this function TS. So, in this case, as you can see, I am just mentioning the starting point and the frequency. So, here frequency is actually telling me that in 1 unit of time, so which is here assumed to be 1 year, how many data points are available. So, since this is monthly series on ridership, so therefore, there are 12 for each of those months we have number of riders information available. So, the series is going to be, this particular object is going to be created accordingly. So, let us run this. So, you can see time series vector has been created, 159 observations. Now what we are going to do is we will create our predictor, the single predictor that we have, that is time index. So let's so time index, let's first capture the number of observations in this time series vector, which is going to be equal to the number of index values that we will have. So let's run this, and then we will create a sequence for this variable t. Now let's append this variable into this existing data frame. Now let's have a look at first 6 observations. So as we can see here, first 6 observation, we can see second column riders and the third column is having t, which is the time index. So as you can see, the values of it 1, 2, 3, 4, 5, 6. So in this fashion we are going to use it. So next step is going to be about trimming the time series. So we will trim the original time series that we have just created, and the earlier period is going to be used as training set, and the later period is going to be used as a test set. So you can see I am considering first 147 observation as part of training set, and remaining 12 observations as part of test set. So let us go forward with this. So these two sets have been created. Now to fit a linear trend, because we are going to use regression based forecasting. So you can see I am calling the same function that we had used when we discussed multiple linear regression in our previous course. So lm is this function is being being called here, and the first argument is the formula, the model equation that we have. So we are regressing riders, that is number of riders on t, that is the time index, and the appropriate data is also has been specified in the second argument. So let us run this. Now let us analyze the results. So you can see both intercept and this single predictor t both are significant. The model is also significant as indicated by other statistics given in this result. So there seem to be the model is significant, the value of the estimated coefficient is 1.2 for the single predictor t. So significance of this sort of linear trend, we can say that this linear trend is significant, it is fitting to the it can be fit to the series, but we will have to check for the performance, right. So what we will do is now we will score the test data set that we have created to be able to compare the performance of this linear trend model on training and test. So let us call this function predict. First argument is the model object that we have just created, and we will pass on the test data set. So let us compute this. So it has been computed. Now we are going to compute certain matrix like we used to do in previous course. So as we have talked about in previous few lectures, that the matrix that we are going to use in time series forecasting are same like we used in supervised learning techniques module. So this is the package that we typically use, library R minor. So this package has this function m metric, which can be used to compute values for different metrics like SSE, RMSE, ME. So we are going to focus on these 3 metrics in particular. So let us load this particular package. So now let us call this function m metric. So in the first argument, as you can see, we are passing on the this is being applied on the training set, and we are using the first first argument is about the riders, number of riders that are there. Then the fitted values, so the values which have been forecasted by the model, the linear trend model that we have, and we will be able to compute these 3 metric SSE, RMSE and ME. So let us run this. So, we can see the numbers here, RMSE value and ME value. So, the error seems to be about 162 there. Now, let us look at the performance numbers of test partition. So, here also first argument is as you can see here, we are applying this on test partition, number of writers is the first argument. The second argument is the scored values using the model that we have built using linear trend and the same matrix. So, let us run this. You can see the numbers. Now, if we compare these numbers, then we can see the RMSE value for the training partition was 162 and the RMSE value for the test partition is 210. So, there is significant difference in these two values. So, the model does not seem to be performing well on the validation partition. So, even though the model was found to be significant, the single predictor that we had used T, that is time index, was that relationship between the riders and T was found to be significant. However, looking at the numbers, the performance numbers, these value RMSE values, we can see that the model is not doing linear trend model is not doing a good job of predicting the ridership numbers on validation data set. Similarly, if we look at the third metric, that is ME, there also if we look at the training partition, the value is near about 0. We can see here this value is closer to 0. If we look at the ME value for the test partition, it is about 169. So, the model is over predicting by a significant high margin. So, this does not seem to be an adequate fit. So, let us now analyze the same thing using the visual inspection, like we talked about in previous lecture, that visual inspection of time plots and other techniques that we talked about, that is going to be very important in terms of analyzing whether a model is adequate enough or not. So, we are going to plot create few graphics for the training set. So, last observation for the training set was this one. So, this value was March 2016. So, now you can see we are creating a new time series object, rather subsetting a new time series object from TSV, which starts from 2004, just like the original time series vector, and ends at this point, which is also the end point for the training data set that we have. So, let us run this. We will get this series, training data set series. Let us plot this series. So, we can see here this has been plotted. Now, the linear trend model that we have just fitted, we are going to plot this this particular fitted model. So, first we will extract the time index from this time series object, because that is going to be the later on you can see in the second line we are calling this points function, which is actually going to create a line for us, because you can see here third argument we have a specified type as L, which is actually the line segments. So, using this this particular function, point function, and the coordinates, T index indicating x coordinate and the second mod fitted values indicating the y coordinate, we are going to plot the fitted model. So, let us run these two lines. Now, let us call this. You can see, because the color we had specified as red. So, if we zoom into the model that zoom into the plot that we have just created. So, this was the original in the black, we can see the original training set series, and the linear trend model that we have just fitted we can see in the red color, it is just going right through it, and we can see here from the visual inspection of the time series itself, we can see that time series looks to be following more of a U trend, U shaped trend. However, what we have done, we have fitted a linear line. So, even though it was found to be significant, which is also quite obvious from this from these plots also. But it is not adequately capturing the series trend. So, the same can also be confirmed by plotting residual series. So, that is the next thing that we are going to do. So, let us create another plot. Now, this plot is the residual series plot. So, the model that we have just built linear trend model, if we create this plot, you can see we are creating a time series object out of residuals, and the same is being plotted. So, let us run this. So, this is the plot. Now, if we zoom into this plot, we can see that despite the model and the prediction that has happened, the model was linear trend model was found to be significant. If we look at the residual series, clearly the pattern that was visible in the original series, the same pattern is still visible in the residual series. So, therefore, this pattern has not been adequately captured by the linear trend model. So, therefore, we need to do something else. So, let us go back to our discussion. So, as we talked about the adequacy of trend safe. So, we saw that linear trend model was found to be significant, but whether it was adequate trend safe or not. So, these are few things that can be done to find this out. Estimated coefficient and their statistical significance. So, that indicated that it should be adequate. Then from the time plot, we could see that the fitted when we plotted the fitted model, there seems to be it was not seem to be adequate fit. Then if we looked at the difference in the magnitude of error matrix. So, RMSE and average mean ME, those numbers clearly indicated that the model was not doing good on a new set, that is validation set. And in the residual series also we saw that the shape that was there in the original series was still part of the residual series. So, therefore, model was not able to adequately capture it. Now, the next trend shape that we are going to model is the exponential trend. So, what we mean by exponential trend? So, this typically implies a multiplicative increase or decrease of the series over time. So, how we can express this in the mathematical form? So, we can see here y t, and we can see c multiplied by e to the power beta 1 t plus epsilon. So, this is how we can express the exponential trend. If we want to fit this trend using the linear regression model, we can take log of this equation and rewrite it in this fashion, log y t beta 0 plus beta 1 t plus epsilon. So, now we can see that this model fits a linear regression of log of number of riders on time index. So, therefore, the output variable will change, instead of y, now it is going to be log of y, and the RHS part is going to be remain same, where we have the single predictor, that is time index. So, since the output variable has changed, so because of this, if we want to compare the results of linear trend and exponential trend, so we need to do certain we need to do certain computations before that. So, few points are mentioned here. So, comparing candidate models with different output variables. So, if we are comparing linear trend model with the exponential trend model, linear having the output variable y and the exponential model having the output variable as log of y. So, forecast can be forecast, for example, exponential trend model, those forecasts can be computed back to original units. So, once that is done, then we can of course compare the results of the model. So, as you can see here, linear trend versus exponential trend, if these are the two candidate models. So, essentially the output variable is going to be y versus log y. So, we can take exponent of a model forecast for this one log y model, and we can obtain the forecast in original units, and once that is done, then the numbers that we compute after that, they can be compared, and we can compare the performance of these two models. So, let us go back to RStudio and let us see how this can be done. So, first we need to compute this output variable that is log y, that is log riders. So, you can see here we are just computing first line, we are taking log of this value and we will compute this variable, then we will append it to the existing data frame. So, let us have a look at the first 6 observations. We can see here another column has been added, log riders, and the values are there. Now, we are going to repeat the same process. First we will trim the data set. So, let us run this training set and the test set. Now, if we look at the model equation, we are again calling LM function, and now instead of riders that we had used in modeling linear trend, now we are using log riders and then regressing it on T. So, let us run this code. Let us have a look at the results. So, now we can see still this just single predictor T, it is still significant. So, from this model result also we can say that exponential trend is fitting to the data, it in as per the results, linear regression results, it is comes out to be significant. So, now let us score the test data set values. Now, let us compute the matrix. This is for training partition, this is for test partition. So, we can see here that in terms of performance of model on test partition, now the gap the performance is good enough on the test partition. If we compare this back to the performance of linear model on validation set, so there was significant gap here, but here the model seems to be improving in terms of performing on new set, that is validation set. We look at the RMSE value and also ME value, so that difference is, that gap is closing down. Now, if we look at the, because this output variable is different. So, if we want to compare the results of linear trend model with exponential trend model, first we need to recompute these forecasted values to original scale. So, we are just going to do this. We will call this function exp to take the exponent of forecasted results. Let us compute this. Now, we will have to compute the new residual values in the original scale. So, let us do this. Now, these are going to be the values for the test data set. We can see in the original scales for exponential model. So, you can see predicted values and residuals are here. This is for test partition. Now, we can compute the matrix also using the original scale values. So, we can see here the value comes out to be RMSE 213. Now, if we go back, so this is the result of exponential model on test data set. So, RMSE value is 213 and ME value is 173. If we go back to the results that we had earlier for a linear trend model, so we will have to go back. So, you can see here 210 and 169. So, in terms of numbers, if we see that linear trend and exponential trend, it seems that linear trend is doing better than exponential trend on test data in terms of numbers, right, RMSE value. So, when we go back to the original scales, it seems that linear trend is doing better than the exponential trend. So, till now in this lecture we covered the linear trend modeling and exponential trend modeling. So, we will continue this discussion in the next lecture, and we will cover the polynomial trend. So, we will stop here. Thank you.